Afternoon, everyone. My name is Shawn Sims, and before I begin, I just want to say it's really an honor to be here, to be amongst such crazy amounts of intellectual and creative capital is just very humbling. So, without further ado, myself and my partner, Golan Levin, who actually had to fly back to the US today, we'd like to present to you the Free Universal Construction Kit.
Mein Partner,
You can, and much more with the free.
Start it over with some sound for you.
Hey kids, ever wanted to connect your Legos and Tinker Toys? How about your Duplos, Bristle Blocks, and Lincoln Logs? Now you can, and much more with the Free Universal Construction Kit. The Free Universal Construction Kit and the special Universal Adapter Brick allow you to combine all your old playsets to create something new. Think outside the box with this amazing collection of adapters. Connect toys which previously couldn't fit together. Create strange new hybrids, monsters, and mashups. Imagine an endless world of designs. The Free Universal Construction Kit is available on thinkfirst.com. Some assembly required.
I still like that part. So, in its simplest terms, what we have is we have closed system toys, right? So we have Duplo, Tinker Toy, Lincoln Logs, Legos, all these things that a lot of us played with as children. And it's really interesting because they're really meant to sort of like teach you about systems and building, but they're all closed systems, right? So sure, you can try and fit them together, which I definitely tried to do and use tape and glue and all sorts of stuff and tried to make these hybrid toys, but in reality, it's quite difficult. So
what were you trying to do?
I'm trying to connect this into here and then make it like a car and connect this then there.
But okay, this is what kind of toy? This is what kind?
Connect.
And what's the other one?
Finger toys.
And do they fit together?
No, my thing is that I'm trying to make a car that is kind of like this.
So wait, so what's this kind here?
Zoom. Zoom.
So you're trying to connect what to what?
This to this to this.
So that's three different systems. Do they fit together?
That's what I'm trying to figure out.
Oh, that's a problem, huh?
Yeah.
So I definitely wasn't alone, right? And I feel like a lot of kids were like this. So now that we have a few skills with 3D modeling and some manufacturing techniques, we say challenge accepted, okay? Let's get into it. So what we have is we have adapters between 11 different popular toy sets, right? So you can go from any one of the 11 to the next with a simple little connector piece, and it allows you to make some crazy mashup pieces like this, right? So we have Lego to connects here and then some guy standing on top. In the background, you see Duplo to Tinker Toy. And then this is one that's like, typically for a bit younger children, they're called Bristol blocks. They have names all over the world, but they're basically just fingers that sort of slide into one another. But then this is connecting to like very high geometry toy. This is actually done by some scientists. So, we have all sorts of, different toys, but I think before I get quite into about the toys, I think I want to tell you a bit about how these are made and why it's really important today. So these pieces are all 3D printed, and this is very different than the way I think we've been thinking about manufacturing in the past. This is the image we're used to seeing, right? Like massive assembly lines where most of your consumer goods are made, and they're cheap because they make lots of them and they make them really well and really fast. So it's good for business, right? It's great for an economic model that you have to sell things and make money. So, but there's something sort of significant that we miss, that mass customization is lost, right? So every piece is the same. So if you want something that's a little bit different, you can't get it from this factory, right? So we tried this with robots, right? So your assembly line that makes your car makes a bunch of different cars, but it's still working on a closed system. So everything is still it's running a computer program, and it maybe picks between 1 and 5 programs to run. And I think the really interesting thing about these is repetition and accuracy, right? That's why we use robots. So what if we could take that and put it in the hands of the consumer or the end user, right? So this is the new model for manufacturing. Totally different. Sitting next to me on my desk in my computer, and I'm able to make these plastic parts or toys or doorknobs or replacement parts for my car, whatever it is, right? This is the way that I think we need to start thinking. And really, if we can, take the lessons from the robots and the assembly lines, where we're able to, take the scale of these things and then distribute it. So, this is one of my favorite quotes. So it says, "Though still in its infancy, personal 3D printing technology already shows the same disruptive potential as the original printing press. Just as movable type spread across Europe and democratized knowledge, the proliferation of 3D printers eventually promises to democratize creation." That's huge. It's huge to me. In a way, it's like rebelling your status as a consumer. No longer do I have to go buy things from China, or I don't have to go to Toys R Us, or I'm not sure what your local toy store is here, but you don't have to go there. These things are coming to you, right? So this is sort of counter to what the Industrial Revolution was all about, right? That we were all able to save money because everything was made on the same assembly line. And now we're sort of like messing with that entire system when we start talking about everyone having 3D printers on their desk, everyone having access to these machines. And it's a ways off, but follow me for a few minutes and you'll see. So this is one of the 3D printers that we use to make a few of our pieces. And I'm sure lots of you are familiar with 3D printing, but if you're not, 3D printing is basically one of the processes that you can turn three-dimensional digital files into a three-dimensional physical object. Right? So you could think about it, I'm squeezing my toothpaste out or icing on a cake. And so if I begin to squeeze it and move it around and move the tube in 3 dimensions, you'll probably have a mess, but it'll be 3 dimensions nonetheless. So if we do that with the precision and accuracy of a machine, well, you can start making some really interesting things. So if you actually look on the left side, this is, we call it a home 3D printer or, hobbyist 3D printer. This is a MakerBot. This is made by these guys that started in a warehouse with 7 people in Brooklyn, and now they're everywhere. And they're pretty cheap, relatively. Still cost some money, but considering that industrial 3D printers were costing, of the same quality, were costing about $30,000 5-8 years ago, we're getting there, right? So you can see a bit about the process and the way that it is building up layers, and this particular piece is between Lincoln Log and Connects. So Lincoln Log is like, I think, a pretty American toy where we build little houses out of wood. And so, because it's made by a computer, we have a digital file. And so we share them, just like you email one another a page to print out on your printer at home, we can email each other a 3D file that you can 3D print somewhere. And this is where it gets really interesting, because this is where the sort of core of the distributed model of manufacturing happens, right? Because it's a 3D file, because we can host it online, we can share it with anyone, and anybody can come and get it. And this is actually, these are screenshots of where we're hosting our files, and if you're on your laptop now, you can go download it. They're there for you to get. We're not selling them. You can just download them and have your way and make new crazy toys. So there are a few places, right? Like you might say, I don't have a 3D printer. First of all, I don't know what a 3D printer is. I sort of maybe get it now that Shawn said something. I don't know where one is. What do I do, right? So there are a couple of websites that you can go to. And just like you upload, I don't know, maybe you upload a photo album you made and you get sent a cute little binder of your holiday pictures. Well, instead you get a box of your 3D print, right? And The prices of ours vary. Some are as cheap as $3 US, and some are $20 US. But in the end, you have pieces like this. So these are all sort of the Lego family, and they're all connecting to something else. And I think probably in Europe, much more in the US, you might notice the top middle one is Fisher Technic, which I think is probably my favorite one, and unfortunately I didn't have it as a kid. So it's basically half of one, half of the other, right? And this is huge when you start thinking about combining all of these, all right? On the left is actually what we call the universal adapter brick, and it's kind of our metaphor for the project. Everything gets mashed together. Everything is possible. And so we have, I don't have to read them off to you, all those toys, right? And the tricky thing about this is the reason why they sold is because they were on patent. So I'll get a little more into the legal stuff in a few minutes, but I mean, these are complex geometries, hyper-precise toys, and making a replicant of one of these and reverse engineering it to the degree that they make it in a factory is actually quite difficult. So we use a couple of older machines that have some new digital add-ons. So this is called an optical comparator. And you basically shine a parallel beam of light onto an object. It bounces off some mirrors, and it makes that shadow really big. And then you can see there's a little arm right here. And on the end of that arm is a little fiber optic tip, and it tells me when I'm in shadow and when I'm in light. And then you kind of turn some knobs, and it is really accurate. I mean, we're down to 2.54 microns. So we're down there with the accuracy that these robots and these manufacturing lines that are typically doing, injection molding plastic, basically we're right there with them. So, in the end, then I basically sit on my computer and pull my hair out while I 3D model at this scale. And in the end, you're left with something like this, right? So this is how the file sort of starts, and then this is what I was spinning around on my computer for 3 months and driving myself crazy and thinking about how do you get all these to play with one another. And it really is quite a difficult thing, and there were so many aspects of playing with toys that I sort of oversaw. You hear the click and you feel the snap, right? These are sensory feedback loops that I think I was oblivious to, and now that I tried to reproduce them, I almost went mad. And I have a tremendous respect for these guys at Lego and Fisher Technic now, and these empires that they've built. But so basically, this 3D file then goes into a 3D printer, right? So I showed you a home one. This is the one we actually use to research. This is an objet. This is basically made from resin, and then it's cured with ultraviolet light. And the resolution of this machine is, you're basically not prototyping anymore. You're making one-off products. I mean, it really is of that quality. And so, just to show you a few pieces, and, and so these are gears, so you can basically plug in these toys, and you turn some knobs, and these toys begin to rotate, which is kind of fun. These are the Tinker toys, which I'm sure a lot of people are familiar with, but I remember specifically taking tape and duct taping a Tinker toy to my Lego as a kid, and it only holds up for so long. So you can think about this, right? I think this is a good picture that shows you a bit about the scale and the sensory, right? So when you're pressing these pieces together, it's actually quite difficult to reproduce that feeling, and especially with Kinects, because there's a nice snap that it has. And taking that system and going on, and we can make all these sort of crazy mashups, and so this is our sort of matrix. So these are the legal ones. These are all off patent, so they're absolutely perfectly fine for you to reproduce these forms. You might run into some problems if you try and sell them and call them Lego. You might get a nasty letter from Lego, but we're not calling them Lego, we're just saying that they happen to work like them. And these are the legal ones. We also started working with ones that, if you go to our site, they'll say they're coming in 2015 or coming in 2018. It's because we have to wait for the patent to end before we can actually distribute them. And this is, just a quick reference. This is basically what a patent looks like. And this is what the Lego patent looked like on the right, which ended last year. And it was kind of huge. Now you're seeing lots of replicas come out, and the sort of toy world's changing. And I'm personally kind of wondering who's going to embrace that, right? Because we're not going to keep buying pieces of plastic if I can make it at home and make it much cheaper and much more awesome than the pirate kit I can buy at the store or what have you. And the one on the left is Zoob, which is actually a fairly complex toy, but it is on patent for about another 6 years. So because these toys are basically in a gray zone of legality, there was some hesitation about releasing them. We actually got really excited. We were like, this is amazing, I wanted this, let's give it to the world. We had some nice fellows from Public Knowledge and the Electronic Frontier Foundation in Washington, D.C. We sent them just an email like, hey, we're gonna release this, you might like it. You've been blogging about 3D printing. They get on an airplane and show up in Pittsburgh, and they said, you're crazy, don't do this. So we sort of freaked out, right? Like, we were like, oh my God, we're gonna get sued by every toy company that I ever loved, and my whole childhood's gonna come crashing down on me. And so we sort of stepped back, and what we ended up having to do was create this sort of hybrid Creative Commons license. And we had a lot of nice lawyers that, sort of came and helped us out and sat down, and I would have to give a whole nother talk on the legal side to really get into it, because it's quite complicated, but I learned a lot. But the one thing we want to make sure of, no matter if anything went down legally and we had to get rid of this toy, we were going to make sure to bury it on the internet as a torrent, right? It'll live forever. It's a time capsule. Once somebody uploads it, downloads it, it's out of anybody else's individual hands. So, I mean, that meant a lot to us, right? Like, we finished this thing, and we got scared by lawyers, so we took the legal route and handled all that, but it was also our sort of artist hacker rebellion. We were like, forget these guys, we're gonna put a torrent on the internet, right? So, in the end, I think what we're really trying to do is lay down a precedent for people that are trying to think this way, and I think it does two things. One is it's helping us tell you here, right? You can reverse engineer things. You can make hybrids, remix, right? That's the word. We can make remixes. And it's okay, right? You just have to do your research and know what's possible and what you might get in trouble for. But the other thing is that the medium, right? The medium through which we spoke about these topics was toys. So immediately we're gonna start talking to a generation that I wish I was thinking this way as a kid. And so it's simultaneous. It's sort of the simultaneous world that we're trying to make about thinking new possibilities. So I'm done, but I'll leave you with one thing, and that I'm not sure it's so much about rebelling against these things as much as it is I really have the desire, and I hope we all do at some point, that we can make a future that we don't have to rebel against. And I don't know. Thank you very much, and make awesome stuff.